All right, let's dive into one of the most mysterious, most misunderstood objects in the entire universe, the black hole.
We've all seen them in the movies, right? They're always the big bad, these cosmic monsters that devour worlds, these portals to other dimensions. They're sensational, they capture our imagination, and let's be real, they're just incredibly cool.
But what's the real story? Beyond all that Hollywood hype, what does the actual science say? Well, today, we're going to separate the facts from the fiction and get to the bottom of what a black hole really is. So to really get past all that sci-fi stuff, we have to start with a solid, scientific definition. Let's just clear the air and get down to basics. The name black hole is actually kind of misleading, because it's not a hole. It's not empty at all. It's the complete opposite. Imagine an incredible amount of stuff, of matter, squashed down into an impossibly small point. That's what it is, the most concentrated point of gravity we know of.
Okay, so now that we have that in our back pocket, let's start busting some of the biggest myths out there.
Okay, myth number one, and this is the big one, that black holes are basically cosmic vacuum cleaners, just roaming around space, sucking everything up. The reality? Well, their gravity works just like any other massive object, until you get extremely close.
Here's a great way to think about it. If, right now, our sun was magically replaced by a black hole that had the exact same mass, guess what would happen to Earth? Nothing. Absolutely nothing. We just keep on orbiting like we are right now. See, that super powerful gravity is only a real danger when you're right on its doorstep.
And then there's the other huge sci-fi idea, right? That there are portals to other universes. I mean, it's a cool concept. And yeah, theoretical physics has ideas about things like wormholes, but there is literally zero evidence for it. Crossing into a black hole isn't some grand adventure. It's a one-way ticket to getting crushed into a single point called the singularity.
So that idea of a one-way trip, that leads us to a concept that's maybe just as famous as the black hole itself, the ultimate point of no return. And that point is called the event horizon. It's like the ultimate border. Once you cross that line, gravity's grip is so ridiculously strong that nothing, and I mean nothing, can get out. Not even light, the fastest thing we know of. It is literally the point of no return. Okay, but that brings up a really good question, doesn't it? If they're invisible, because no light can escape, how in the world do we even know they're there? Well, it's because astronomers are basically cosmic detectives. We can't see the black hole itself, but we can see the crime scene, the effects it has on everything around it. We see stars orbiting, well, nothing, just empty space. We can detect these massive bursts of X-rays from gas and dust getting superheated as it spirals in. And we can even see how its immense gravity bends the light from distant objects behind it, like a giant lens.
So what happens if you do cross that event horizon? Well, it's not pretty. There's this process, and it's actually called spaghettification. Yeah, seriously. For smaller black holes, the pull of gravity on your feet would be so much stronger than on your head that you'd be stretched out like a long piece of spaghetti. It's a bizarre and, yeah, a pretty violent way to go. But wait a second, hold on. We just said that to escape, you'd have to go faster than light. And I'm pretty sure we've all heard that nothing can go faster than light, right? It sounds like a total contradiction, a violation of a basic rule of physics. But the universe? Well, it has a very strange answer to that.
So, is there anything faster than light? And the mind-bending answer is yes, the expansion of space itself. Now, this is a key distinction. We're not talking about something moving through space, like a spaceship. We're talking about the fabric of space-time itself stretching and basically carrying things along for the ride.
And this isn't just some crazy theory, we can actually see it. There are galaxies out there so far away from us that they're receding, moving away faster than the speed of light, not because they're flying fast, but because the sheer amount of space between us and them is expanding at an incredible rate. It's one of the weirdest, most profound consequences of Einstein's theory of general relativity.
Okay, so if these things just gobble up matter and nothing ever gets out, they must last forever, right? They're eternal. Well, that's another myth we need to bust.
It's all thanks to the legendary Stephen Hawking and his idea of Hawking radiation. Now, it's super complex quantum stuff, but the gist is this. Right at the edge of the event horizon, tiny particles are constantly popping in and out of existence. Once in a while, one particle from a pair gets sucked in, but the other one escapes. That escaping particle carries away a teeny tiny bit of the black hole's energy. Now, over trillions and trillions and trillions of years, this causes the black hole to slowly, very slowly,
evaporate away.
Okay, so we've got spaghettification, points of no return, evaporating cosmic giants. This is a lot of cosmic drama. So let's bring it back home. Should we, here on Earth, be worried about any of this?
The short answer is a big, resounding no. And the reason why is this number. We're talking thousands of light years. That's how far away the closest black hole is to us.
So yeah, you can sleep soundly tonight. We are perfectly safe. The nearest one is way too far away to ever bother us. Plus, for a star to even become a black hole, it has to be absolutely enormous. Our sun, it's just not massive enough to go out that way.
Look, this sci-fi stuff is fun, no doubt about it. But it can sometimes distract us from why black holes are truly important, why they really matter to our understanding of the universe.
It's because they are the ultimate real-world expression of Einstein's most famous equation, E = mc². They show us, in the most extreme way possible, that mass and energy are really the same thing. A black hole is what happens when you concentrate so much energy into one spot that it literally breaks the fabric of space-time. And really, that's the bottom line. Black holes aren't just monsters from the movies. They're like cosmic laboratories. They push our knowledge of physics to the absolute edge, and they remind us that the more we learn about the universe, the more we realize how much we still don't know. It just makes you wonder what other incredible secrets are out there, hiding in plain sight, just waiting for us to find them.